Welcome to AP Calculus Section 7.4. Some of 7.4 is not going to feel like calculus at all once we get to some story problems, but the beginning of it certainly is. We're going to be dealing, as you can see, with exponential growth and decay, half-lives, could be investment problems with continuous compounding, and basically we could have one formula kind of fit all. Now, last year we did some different things with the way we set up our formula for half-life just so it makes more sense to us. But let's go ahead and get started. You'll see where I'm heading with this. The quantity y increases or decreases at a rate proportional to. So its rate, dy dt, equals proportional, that's our constant of proportionality, just k, just think of it as a constant, times y. If we also know the amount at time equals t, we can solve this initial value problem. So to solve this initial value problem, I want to group my y's with dy. So I'm going to multiply by 1 on y, leave k, multiply by dt on both sides. To eliminate our dy dt's, or dy's and dt's, I'm going to integrate both sides, and I get ln absolute value of y equals kt plus c. Now, could have had a plus c on the other side, but I just consolidated those into 1 plus c. They're constants. We can do that. All right, at this point, I'm going to go ahead and figure out what c is. If I put in y naught, y is y naught, so I get ln y naught equals, when t is 0, I get c. So c is ln y naught. You'll see where we're going with that. So at that point, my formula is ln of y equals kt plus ln y naught. And I think I might be tempted to take e to the on both sides. We got to get y out of that ln, so absolute value of y equals, I'm going to make this e to the kt times e to the ln y naught. And I can do that just for the reason x to the 5th we know is x to the 2 plus 3, and we know we could write that as x to the 2nd times x to the 3rd. They all mean the same thing, so no algebra laws broken there. Let's see where we're going with this. We've got e to the ln y naught. That is just y naught. So right now, I'm going to talk about the absolute values in just a second. I get y, or absolute value of y, equals initial value e to the kt. Let's talk about the absolute values. If this is an initial value problem, then y naught, the amount I start with, is going to be a positive value. E to the kt is always going to be positive. E to the graph of it looks like this, is always going to be a positive value no matter what, whether this is positive or negative exponent. So we end up with the amount. A lot of times I'd like to just say this, amount at time t equals the amount we start with, e to the kt. So we have that. You might like this formula just so we realize that's the amount at time t. So no big deal. It's just last year we got to here without going through this proportional rate initial value type problem. So kind of nice at times to see where things come from. Okay, half-life. Last year we worked with the half-life problem perhaps of amount at time t equals initial amount times 1/2 to the t on the half-life, and that the book will actually basically use this formula to come back and arrive at this. I believe in chemistry maybe you just started with this formula. So probably a good formula to know. We've got an avenue to get there, but we'll probably go back. We'll probably use this one. Okay, use separation of variables to solve the initial value problem. It's what we just did on the previous page. I want to get my y's together. Multiply both sides by y. I want to get my x's together. Multiply both sides by dx. I want to solve for y. Well, I'm going to have to integrate to get rid of that dy, and I get y squared on 2 equals x squared on 2 plus c. Now, as soon as we're out of the integral, unless you see something that you really want to do to try to make things be a little bit easier, we're going to go ahead and figure out what c is. So when y is 2, I get 4 on 2, 2, When x is 1, I get 1 squared 1 on 2, 1/2, and we see that c is, this is a plus in here, subtract 1/2, c is 4/2 minus 1/2, 3/2. So we've got y squared on 2 is x squared on 2 plus 3/2. Let's solve for y. I get y equals, I'm going to multiply everything by 2, and I'm going to take the plus or minus square root of. And now we're going to consider that this is x squared. We're going to consider this plus or minus. Well, y is going to be, could be a negative value, but because we were dealing with positive values here, we're only going to use the positive portion of that, because this would represent a curve to us, and we're only going to use the top half of that curve for our y's. So we get square root of x squared plus 3. Now, to indicate the domain over which the solution is valid, we need to consider the x values here. Is this a continuous, excuse me, is this a continuous function? Can I put any value I want in for x? Yes, I got problems with y, but I can put in any value I want for x. Therefore, this is continuous. Then the next thing we check is this. Can I put anything I want in here for x? Well, there's square root, which causes a problem sometimes, but not in this case. So this is valid over all real numbers. Okay, we'll see one real quickly here where they're not. Okay, in fact, right away on B, I note this is not a continuous function at x equals 0. X cannot be 0. So, in fact, we can come back and talk about the graph about that in a moment. But let's go ahead and group our y's. I got 1 on y equals 1 on y dy equals group our x's, 1 on x dx, integrate both sides, ln absolute value of y equals ln absolute value of x plus c on one of the two sides of integration. At that point, we can probably figure out what c is. Let's put 2 in. I get ln absolute value of 2 equals ln absolute value of 2 plus c, so c is clearly 0. So we're dealing with just this. e to the, and we get absolute value of y equals absolute value of x. And now let's consider what's going on, because x cannot be 0. X cannot be 0. Therefore, if x can't be 0, in fact, we're looking at this curve right here, if we were to graph that. If x can't be 0, well, x could be negative, which makes this absolute value a player. But the portion we can only talk about, due to the discontinuity, we can only talk about the portion to the right or the portion to the left. And since the point they gave us lies on the right, it's not exactly that point, but it's to the right, the x value is to the right, we're going to say this is valid on the interval, the continuous interval 0 to infinity. Okay, let's take a look at C. First off, we might want to get in the habit of deciding, can I put any value in here for x I want? You bet I can. So unless I get something peculiar in the solution, then we can, at this time right now, let's just put it this way, at this time right now we can go ahead and plan on having this be valid on all real numbers. Well, let's group our y's. We'll see, well, ln's pop up, so maybe we'll have some challenges. ln, not there yet. I tried to skip a step. 1 on y plus 5 dy equals x plus 2 dx. Integral both sides, and I get ln absolute value y plus 5 equals x squared on 2 plus 2x plus c. Let's find c. Y is 1. I get ln 6 equals x squared on 2 when x is 0 plus 2 times 0 plus c. So c is ln 6. So at this time our equation is ln y plus 5 absolute value equals x squared on 2 plus 2x plus ln 6. All right, got a little sneakiness here again. I'm going to solve for y by taking both sides, making it e to the. That gives me, still have my absolute value, y plus 5 equals, I'm going to write this as e to the x squared on 2 plus 2x times e to the ln 6. Why didn't I separate this into e to the x squared on 2 times e to the 2x? There's no payoff, but there's a payoff to get this alone. So I have absolute value y plus 5 equals this is 6. 6 times, don't need the parenthesis, e to the x squared on 2 plus 2x. But e to the is always a positive number times 6 is always a positive number, so y plus 5 is always going to be a positive number, so I don't need to do anything with the plus or minus thing here. Just y plus 5 is 6 e to the x squared on 2 plus 2x. And I'm going to take a break at that point, and we'll come back for part 2.